This is Junose from HITS School of Welding Technology. So I will be discussing on how uh, a WPS is being prepared. Okay, how to prepare a WPS. Okay, there are many steps in preparing the WPS that you need to understand. Okay. By the way, before we proceed on the steps, okay, I would like to define, okay, or discuss what is WPS. WPS is a welding procedure specification. Okay, as per the definition of AWS 8.3.0, a WPS is a document providing the required welding variables for a specific application to assure the repeatability by properly trained welders and welding operators. Meaning, if you have a WPS, you can use it repetitively, okay, uh, to have a good and sound welds. What is WPQR or PQR? We call it PQR or Procedure Qualification Record. Okay, taken from the AWS 8.3.0 definition again. Okay, a PQR or a welding procedure qualification record is a record of welding variables used to produce an acceptable weld or acceptable test weldment and the result of tests conducted on the weldment to qualify a welding procedure specification. Okay, so kumbaga parang mag-asawa ito. It's like they are, you know, they go together actually. Okay, which come first? Is it the WPS or PQR? In order for a WPS to be approved, a PQR is required. Thus, the PQR will be the first document which record all welding parameters during the welding of specimen or the test coupon, right? So, what are the codes used in preparing WPS? There are three most common codes used in WPS. These are ASME 9, AWS D1.1, and API 1104. So if your product output is pressure vessel, pressurized piping, okay, you'll be using ASME 9 code, okay. While if you want to do structural welding, okay, then the AWS D1.1 will be used. However, if your product is welding of pipelines and related facilities, then you need to use the APL 1104 codes. Okay, so for the sake of discussion, among the three most common codes, okay, in this presentation, we will use only the ASME 9, okay, because this is the most commonly used, especially in the facilities like plants, okay, and pressure vessels. Right. Before I proceed to others, let me discuss to you the welding variables. There are various type of welding variables. Okay, these are the essential variables, supplementary essential variables, and non-essential variables. What are these variables anyway? Okay, as per QW 251.2, an essential variable, okay, a change in essential variable is considered to affect the mechanical properties, okay, other than toughness of the welded joint. Hence, the WPS must be requalified if the essential variable is changed. So whatever whatever changes, okay, in the essential variables of the WPS, okay, then you need to requalify your WPS. Okay. In the supplementary essential variables, okay, as per QW 401.1, okay, of ASME 9, I'm talking about ASME 9. A change in the supplementary essential variable will affect, okay, the toughness properties of the joint, heat affected zone, or base metal material. Hence, supplementary essential variables become additional essential variables in situation where procedure qualification requires toughness testing. When the procedure qualification does not require the addition of toughness testing, supplementary essential variables are not really applicable. So that is the supplementary essential variable. Okay. While the non-essential variable, as per QW 251.3, non-essential variables are those in which a change can be made without the qualification of the existing WPS. So even it is changed, okay, the existing WPS will not be requalified since it is not considered to affect the mechanical properties of the joint. Though a change in the non-essential variable doesn't require the qualification of the WPS, but still it should be properly addressed in the welding procedure specification. Okay. There are various steps in WPS preparation. First and foremost, you decide which process you want to use. Okay, you can choose from SMAU, GTAU, FCAU, GMAU, or combination of any of the above process. It can be GTAU SMAU, okay, GTAU FCAU, GTAU GMAU, GMAU SAU, whatever. So first and foremost, you need to decide which process you will be using. After you decide which process, second, you decide which material to be used, okay, in accordance to your project, right? Then, whether it's plate or pipe, whether it's carbon steel or low temp carbon steel or low alloyed steel or stainless steel, etc. Okay, so you need to decide which one is applicable to your project. Third, after deciding the processes you needed and material you needed, you prepare a preliminary WPS, or we call it pre-WPS. Okay, you can use the suggested WS format in ASPE 9 appendix. Okay, the pre-WPS data will be used as a guide in preparing the test specimen or test coupon. Okay, so the parameter range of pre-WPS shall be used during welding of test coupon, including the how the test coupon is being prepared. Okay. Number prepare test coupon as per pre-WPS. Okay, so the pre-WPS data will be used as a guide in preparing the test specimen or test coupon. Okay, so the bevel angle, the root gap, the root base, it will be taken from the pre-WPS, okay, or preliminary WPS. Step number 5, okay, weld test coupon as per pre-WPS. Okay, the parameter range of pre-WPS shall be used during welding of test coupon. Okay, no other else. Okay, you need to use the pre-written the pre-WPS. Okay, the actual parameters to be recorded in a run sheet. Okay, such as run number, okay, process, polarity, electrodes, volts, amperage, preheat, interpass temperature, run-off length, travel speed, and heat input. Okay, and record the welder name and the welder number. Okay, so the all the actual parameters or needs to be recorded in the run sheet, including the thickness of the thickness of the coupon. Okay, diameter of the pipe if it's pipe. Okay, all the needed data must be recorded. Okay. 6. Okay. After the um, after the test coupon has been welded, okay, you need to conduct visual inspection on the completed coupon. Okay, you need to ensure, okay, that the completed or welded test coupon is acceptable as per code. Okay, uh, before you, before or after, I mean the the weld is completed, it must be ensured that the visual inspection is acceptable. After the acceptance of visual inspection, you can send it to the for NDT. Okay, you need to ensure that the completed and welded test coupon NDT result is acceptable as per code. Okay, you cannot continue, okay, the processes until the all the processes like visual NDT are accepted. Okay, so once the NDT is acceptable, NDT result is acceptable, you can send the completed test coupon to or for mechanical testing. Okay, so you send for tensile test, guided bend test, macro, hardness test, toughness test if required. Okay, so you send for mechanical testing in a laboratory. Okay, in the laboratory they will do all the mechanical testing in accordance to the specification that you will be providing. Okay, so if you provide your project specification, they will follow your project specification requirement. Otherwise, they will use ASME9, right? Next, once the mechanical test is are acceptable, okay, you finalize PQR. Okay, upon receiving the accepted result of visual and detailed mechanical testing. Okay, so you use the suggested format of PQR in ASMA 9 appendix. Okay, so you finalize the PQR. Okay, so all the parameters you put in there, right? All the actual parameters written in the run sheet. Okay, you transfer to the PQR. Okay, uh, upon transferring the PQR, okay, you can create and finalize your WPS upon approval of and signed off of PQR, because once the PQR is signed off and approved, okay, you can finalize your WPS, okay, and send for approval. Or there is also a possibility that you finalize both the WPS and the PQR in one time, okay, and send for approval, sign off in one time also, okay. So once all these requirements, tests, inspection, okay, are approved, okay, and recorded in PQR, then finalized in your WPS, then you will have already your WPS. Okay. By the way, the range of WPS parameters shall be as per PQR actual parameters. Okay, and then you sign off the PQR and PQR and WPS. So once the PQR and WPS are signed off and approved by approving authority and you, of course, okay, you now have an approved WPS. So that is the only time that you will have your approved WPS where you can use in your welding production. Right? Right. Who is responsible in preparing WPS, by the way? Okay. By right, it will be the welding engineer of the company. Okay. He is the responsible person in preparing the WPS. However, as per CSWIP, he must be a certified senior welding inspector or CSWIP 3.2.2. However, in other places, appointed engineers are responsible for WPS preparation, even they are not CSWIP 3.2.2. Even it's sad to admit, okay, it's being done in other places, okay, but by right, it should be the CSWIP 3.2.2 personnel who should sign off the WPS, right, and PQR. So as per CSWIP, okay, that's why we have senior welding inspector, okay. Right. So this is the end of our discussion with regards to WPS preparation. Okay. Our next subject, okay, in our next video, okay, is how to fill up the WPS form as per the appendix of ASME 9. So see you in my next video. Okay. And thank you for watching. This is Junuse. I am CSWIP 3.2.2, Senior Certified Welding Inspector as per CSWIP, right? And I am the president of HITS School of Welding Technology. HITS School of Welding Technology has been in the business since 2008, and we ran various courses since 2008. We have shielded metal arc welding, okay, plate and pipe, gas tungsten arc welding, plate and pipe, carbon steel and stainless steel. We have combination welding, Jitao, SMAO. We have actually FCOW and GMAO as well. Okay. We also conduct welding inspector course, painting inspector course, and NDT courses. We also conduct seminars on ISO 9001 awareness and ISO 9001 auditing. Okay, so those are our courses. Okay, and we have been in the business since 2008. In the Philippines, we also have an overseas projects also already in Brunei. Right, so that's all for me, and in behalf of his School of Welding Technology, okay, this is Junose telling you a very good evening to everyone, and may God bless you all. Thank you very much.